Hi everyone, this is a first video of a series of hopefully many more to come. It is about text analysis in finance. I am a professor for financial data analytics at a German university, and the series of these videos are likely going to be hand in hand, or at least a little bit, with a course that is called Deep Learning and Text Analysis in Finance that you can see here. And yeah, it's an ongoing process, so very likely the content may evolve and change and be a little different when you watch this video. However, I'm trying to link this course book as well if you're interested. But the idea is to make some, a series of short videos that always discuss one of the aspect things that we are doing in this course here, and that include the typical, steps which are, valuable to any kind of text analysis, but then also to take a look at some very special characteristics that may be interesting if your background is more like in the financial domain. For instance, how can we analyze if there is some stock market reaction to reports of companies or news, something like this. So what I'm trying to do today is to show you let's say the second step, because the first step would be to gather text. Text usually, can be gathered by third-party providers. Also, you can access them for yourself. Likely, I'm going to do a video that shows you how to do this for a few different types of text in the near future. But for the moment, let's just skip this, because then the second step is how to pre-process text. Okay, why do we need to pre-process text? That is because usually the overall routine will hand over the text to an algorithm, to a statistical model, to a machine learning model that is then going to be used to analyze something. Analyze can do some predictive task. Okay, for instance, predict the stock market reaction. Can also be some unsupervised learning tasks, such as, okay, please categorize these amount of documents into clusters, which then maybe every cluster is representing a certain topic or something like this. And to make it easier for the algorithms, we need to give them a more easier processable, easier readable, a unique form of the text, and that is why we do certain steps that are considered to be text preprocessing. Okay, for the moment, let's talk about, I would say, the things that are following now. It kind of depends on which algorithm you want to use. It makes more sense to use that kind of preprocessing or that kind of preprocessing. And also would say the more simpler and more older algorithms, they are using simpler pre-processing routines that are still keeping a more human readable nature of the original text. More state-of-the-art models, they tend to what is called tokenize the text into some forms which are, I would say, considered to be less human alike, or how humans process and read such text here. To talk about general how do we refer to the things we're talking about here. So usually everything is a document. That means a document can be in reality a sentence, it can be a paragraph, it can be a page, it can be a whole book or something like this. And then a collection of documents is usually the corpus. Okay, then what we would say as humans, the words, they are usually called the tokens, but there's a more general definition about the token that we're going to discuss later. And the unique amount of tokens is then called the set of terms, and usually that is referred to as a dictionary. Okay, so this is just to have the same understanding about what I'm talking here. Then what I'm having here is this is just copy and paste for a news article of today about Apple. And here I'm doing something that is not necessarily you really don't need to do this necessarily, but I'm doing this here for better readability in this notebook here. By the way, I'm using Python, as many do, so if you want to try this for yourself, you also should become familiar with Python. Also, I'm trying to link this notebook below the video as well. But here in the beginning, then I just split this news article into the sentences that we can read it better here and see it better here in the notebook here. Okay, then let's start with, I would say, simple pre-processing, especially if we want to keep the human readability to some certain degree. Simple pre-processing, I would say, usually includes often the removal of punctuation, the removal of numbers, special characters, and also lowercasing. You can write this for yourself if you are familiar with Python, but I would say here also a very handy method is doing this. All this for us is the simple preprocess method from the Gensim package. And if you compare that, you can see to what this leads here. So in the beginning, we have those sentences. And now here, every sentence is including a sequence of words here. As I said, the words in general are referred to as the tokens. They are all lowercase, and we don't find any numbers or punctuation anymore. This is especially often used if you're using an algorithm that is about, for instance, counting the occurrences or frequencies of tokens in every document. Then this kind of preprocessing, I would say, makes sense. What also makes sense is, especially for those type of frequency-based algorithms, is to drop some words that are not useful in terms of differentiating between the documents, some information. And these are words that occur with a high frequency in every type of document, no matter what the document is about, and no matter about, for instance, things such as the sentiment of the document. And these words are referred to as stop words. Stop words usually need to be defined by the users. But in essence, they are words that occur often in every type of document. And once you remove them, you can see that the length of the sequence is becoming shorter. But that also means that the overall amount of different terms in your dictionary that can appear, so the theoretical number of different types of tokens that can appear for every document, is going to be reduced. And this is making sense, especially if we have this, for instance, frequency-based algorithm that is just taking a look how many times does this term appear in a document. Because if the overall number of terms is smaller, that leads to what is called a lower dimensional representation of each document. That just means every document can be described by a lower amount of different numbers. And this is often very helpful for instance, algorithms that are used later for supervised as well as unsupervised learning tasks of textual input. Okay, so this is one reason why to do it and include this in your pre-processing. Other models which work different, other algorithms, they don't really need this, and then you don't necessarily should or need to remove the stop words. How you can further reduce the overall amount of terms that can theoretically appear in your corpus are things such as stemming or lemmatization. They are different, but I would say the idea or like the goal is similar. For instance, stemming brings different versions of the same word, you can say it like this, to its origin or to its word stem. Okay, so for instance, here in the third sentence, originally we have, on the other hand, the DAO registered a gain of 0.5%. And after stemming, this becomes to, on the other hand, the DAO regist. Okay, so registered to register, it's all brought back to the word stem regist. And if you do this, that further reduces the overall number of terms in your dictionary. So it reduces the number of different numbers that you need to characterize a document, and this reduces further the dimensionality of the representation if you're using a frequency or occurrency based algorithm, accounting algorithm here. If you don't have this, if you use other algorithms, then maybe you don't need to use the removal of stop words or stemming. And by the way, there is no, it's nothing that's written in stone here. It's always try for your corpus, for your certain purpose, what works best. These are all just options that you can consider maybe to improve things. Last but not least, if you keep it more general and approach more state-of-the-art models, the overall process is done by what is then called a tokenizer. And I would say the main characteristics are, now tokens are really not necessarily what we as humans would be considered to be words. The pre-processing itself includes some steps as before, may include, for instance, the removal of punctuation or numbers can be done. But an important characteristic for more state-of-the-art tokenization models is that learning what is considered to be a token is done by an algorithm that has to be trained on the raw original corpus by itself. Okay, so here is the definition. I've written this down here. A token, I think at least by the Stanford research community, and I think this is also in general accepted definition, is an instance of a sequence of characters in some particular document that are grouped together as a useful semantic unit for processing. So that means if some algorithm identifies that a certain sequence of characters should belong together, that is to be considered a token. But that does not necessarily mean it's supposed to be a word or something that we consider to be a word. Okay, so if you take a look here, I'm using here a tokenizer. I'm telling you later more about it, which is quite popular. And just to show you and highlight to you what it does to the original text, and it looks very different. It still includes the numbers and still includes punctuation. But for instance, here we have the accent and S, which is now considered to be a unique token. Okay, so this, even though it belongs together with days. Okay, so this is we as humans read this as days, but the algorithm separates here and says, okay, this is the sequence of characters that should belong together, and this is the one that comes before it, right? So this is the big difference here. And if you want to find more about this, very likely at some later point we're going to talk about this in way more detail. Already right now, I recommend to you to check out what is called Hugging Face. Okay, Hugging Face is a very popular page, especially if you want to do something with more state-of-the-art models. If you go to that page, if you check out the docs for the documentation, and then if you go to the tokenizers, you can take a look here at on the left to the components. You will, if you want to read through it here, you can do some, what is referred to as the normalization and pre-tokenization steps. Okay, things that you may already do when you simple pre-process. So strip accents, strip the white spaces in the beginning and the end of the sentence, stuff like this. Maybe if you want to replace or remove characters or numbers, but then you need to use or train an algorithm that is trained on what to identify to be a token laterwards. So for instance, for the BERT model, it's, I think, the word piece algorithm that has been used, but as you can see here, for instance, here you can choose among 4 different algorithms. They now need to be trained on your original corpus, on the original collection of documents. And once you did this, it's going to identify how to tokenize, how to pre-process the text. Okay, and again, here one more time, you can see that this is really different to the simple pre-processing. But yeah, as stated before, it kind of depends which model you want to use later, which type of text pre-processing and tokenization you may want to use. And once we are going through the following videos to come, I think you will see that sometimes this, sometimes that, and you also can play around with that a little bit. But for the moment, if we summarize, I would say usually what you do is to a certain level you lowercase. That's what most of the tokenization pre-processing steps are doing. You can and often remove numbers, you often remove punctuation, because the exact numbers often are not really informative regarding the information of the text. And lowercasing is done in the beginning. Often white spaces are used to separate the sequence into what is called the tokens, but more state-of-the-art models, they use a tokenization in a more general way, and that means you train an algorithm to identify a sequence of characters to be a token, and then once this is done, you can pre-process and tokenize the original text in that form. And this is how the text is going to be forwarded to different algorithms that can be used for text analysis. And those are the topic for the videos to come. So I hope you like this video here, and then we see each other in one of the next videos. Take care and bye-bye.